Hey guys, today we're going to be solving quadratic equations with factoring. There are several ways of solving quadratic equations. You guys will learn all the methods that you can use. Certain methods are good for certain situations, and obviously this is going to be a method that's used when you can factor the given polynomial. Okay? So, hey, the thing that we have to remember if we're going to be using factoring, we got to remember our master factor plan here. It looks like you guys have already proven you have the skills necessary in order to factor any given polynomial, and that is essential that you know the master factor plan, and not only know it and can follow it, but you have the techniques and the skills there to use those techniques to put everything that's given to you in factored form, okay? So that's really big today. We're going to be using that, finally showing you why we've been working on factoring for the past month, okay? And we're going to use it to help us solve quadratic equations. We know what a quadratic equation is because a quadratic is going to have the highest exponent of 2 in the problem, and we know it's an equation because it obviously has an equal sign. So these are the type of equations that we're solving. When we're solving, we're trying to figure out what x could be. Okay? The key to doing that is that we're going to use what's called the zero product rule. And what the zero product rule says, if a times b equals 0, then a can equal 0 or b can equal 0. Okay, and if a or b equals 0, then the product equals 0. Because you guys know anything times 0 equals 0. Okay, so if a times b equals 0, then a equals 0 or b equals 0. So we're going to be using that as we come down here and we take a look at these quadratics. So you can see here it says solve the quadratics using factoring. Now remember, when we talk about factoring, we're talking about things that are multiplied, right? Things that are multiplied. Okay. So when we take a look at number 1, this is a quadratic. We can see that these two things are being multiplied. These two binomials are being multiplied. So this is perfect. This is in factored form. We can use this property up here, okay? And we're going to think of this entire binomial as A, and we're going to think of this second binomial as B. And what the property says is that if these two binomials equal 0, then x plus 10 could equal 0, or x minus 5 could equal 0. Okay, and that's really easy now. We can figure out what x could be in order for that to be true. X could be negative 10. We get that by subtracting 10 from both sides, or x could be 5. So we can see here with quadratics, we can end up with at most two solutions. Sometimes you could have one, sometimes you can have none, but most of these are going to be two solutions. Most of them two solutions, some of them one. I don't think we'll be seeing too many that are not solvable here. Okay, so number 2 is exactly the same. Okay, that's in factored form. So we see that it's factored form, thinking of this as A, this is RB. So x plus 7 could equal 0. X plus 3 could equal 0. So x is negative 7. X is negative 3. Now keep in mind, guys, if we take negative 7 and plug it back in, negative 7 is the solution that would make our first factor equal to 0. Even though it would make the second one something different. Anything times 0 is 0, so negative 7 works, and the same would work for negative 3. It would just make the second factor equal to 0. Okay? I like number 3. Number 3, we should be able to recognize we have 3 things we're multiplying here: a monomial, binomial, and another binomial, and they equal 0. So it doesn't just work for 2 factors, as the zero product rule states. It actually can work for 3. So if this is true, x could be 0, x plus 2 could be 0, x minus 6 could be 0. Okay, in this case, this is already solved. If x is 0, 0 times anything would be 0, so that's a solution. We subtract 2 from both sides, and we get x equals -2. That's a solution. And we get x equals 6. That's a solution as well. Okay? I usually require for you guys to show how these factors would equal 0 and solve them. And the reason why is because if you see in number 4, we have some fancy binomials here. The leading coefficient in them is no longer 1. So we want to make sure we're writing this step out, and then we're thinking about, okay, how would we go about figuring out what x would have to be? Well, in the first one, we would add 5 to both sides and then divide by 2. So we get x equals 5/2. And in the second one, we would subtract 8 from both sides and then divide by 3. So you notice I'm not showing all my work, but I do like for students to show this step, okay? Just because it's helpful to actually visualize and see where we would go from there, okay? So obviously these first 4 are really good ones to start with. They're all in factored form, but you guys have been around, and if you remember in the beginning of our video, we talked about using that master factor plan. You know, not all quadratics are in factored form like these first 4, okay? So there's a couple things that we're talking about here when we talk about quadratic equations. We say that the equation has to meet 2 requirements, okay? The first one, if you notice up above, all of those quadratics are completely factored. They're all completely factored. So they have to be completely factored, okay? And the second thing is that all of those are equal to 0. So the equation must equal 0 in order for us to be able to solve it, okay? So math is great in the sense that, hey, if it's not completely factored, what do you have to do? You got to factor it. If it's not equal to 0, what do you have to do? You have to get that equation equal to 0. So we're going to have to move some things around. And that's what we're going to see in these situations coming up, okay? I'm going to pick and choose my examples if I feel like it's a little redundant, okay? We're going to end up moving on and do something that looks a little different, okay? So we'll start with number 5. This is a good example to start with. We can see that, hey, this is equal to 0, so we're all set there. However, now the left-hand side is not completely factored. All right, so this is where we reference our master factor plan. We think to ourselves, okay, hey, is there a GCF here? Nope. It has 3 terms, so it can be a type 1, a type 2, or it could be a PST. Okay, so it could be a type 1, it could be a type 2, or it could be a PST. And depending on what it is, we're going to choose the technique we want to use here. Well, we know this is a type 1 trinomial. The leading coefficient is 1. X squared is a perfect square. -10 is not, so it can't be a PST. It's not a type 2 because the leading coefficient is 1. So this is going to be factored down. We're looking for factors of -10 that add to -3. So we're going to break this down into 2 binomials. Don't forget it's an equation equal to 0. And we know that x and x go in those spots there. We're looking for factors of -10 that add up to be -3. So -5 and +2 are the combinations we're looking for. Now keep in mind, the directions here to say to solve. Okay, so now we're going to set our factors equal to 0. I add 5 to both sides. I subtract 2 from both sides. And I've solved our quadratic equation. Okay, so these 2 criteria are super important. We're going to check each and every time for those. We're going to skip number 6. It's very similar to number 5. You can feel free to give it a try. But now we get to number 7, And number 7 is a quadratic, so it needs to meet these two criteria up here. Okay, and we could see here it's equal to 0, so that's checked, but this is not in factored form. So this is a trinomial, doesn't have a GCF, and I can tell this is a type 2, so now I'm looking for the combination of factors of 4, and they're going to combine to -7. So I can go a 1 and a 4, or a 4 and a 1. The combination I'm looking for here is a 1 and a 4, because if I make this negative, I get a -8 on the outside, a +1 on the inside, and now I'm ready to set my factors equal to 0 and solve. I subtract 1 from both sides, divide by 2, and I add 4 to both sides. And there's our solutions for number 7. Number 6 is another type 2 trinomial, so I would encourage you to try that one on your own. And we're going to move to the back for some more quadratic fun. Okay, now what I'm going to do is I'm going to actually stop the video. I'm going to make 2 parts to this. This is going to be day 2, harder quadratics, and you can see here these are not set equal to 0, and they're going to require a little bit more work, and we're going to want to work through all of these to see how these are done. So I'm going to stop the video now. This is going to be titled Part 1, Solving Quadratic Equations Using Factoring, and then you'll have to watch the second video, which will be Part 2. And this will be still considered a one-day lesson, okay? So thanks for tuning in. We're going to get to these harder ones for Part 2 in a little bit. See you soon.